Look at the device you're watching this on. Whether it's a smartphone or a laptop, they all look pretty familiar. Compact, sleek, boring. But if you Google quantum computer, you don't see a black rectangle. You see this. It looks like a steampunk chandelier straight out of a sci-fi movie. Or maybe something hanging in a billionaire's dining room. It's beautiful, it's intimidating, and honestly, it's weird. Why on earth does the most advanced technology in human history look like a piece of Victorian furniture? The answer isn't just about aesthetics. It's about survival. Because inside that golden shell is a battle against the universe itself. Welcome to Quantum Files Official. Today, let's dismantle the chandelier. Chapter 1, The Basics Bits vs. the Cat. To understand the machine, we have to understand what it's thinking. Your toaster, your phone, and your car all speak the same language bits. It's a binary world. A switch is either off 0 or on 1. It's simple, reliable, and predictable. But quantum computers, they don't play by those rules. They run on qubits. And this is where things get spooky. Thanks to a principle called superposition, a qubit isn't just 0 or 1. It can be a complex combination of both at the same time. Think of it like a coin. A normal computer is a coin resting on a table. It's definitely heads or tails. A quantum computer is that coin spinning in midair. Until it lands, it is effectively heads and tails simultaneously. The famous physicist Erwin Schrödinger tried to explain how absurd this is with his hypothetical cat. In the quantum world, the cat in the box is both alive and dead until you look at it. Now, imagine if you could order that cat on Amazon. A normal computer sends you a box with a live cat, or a dead cat. A quantum computer sends you a box where the cat is in a ghostly state of being both. Please don't actually try to ship cats, quantum or otherwise. And it gets weirder. These qubits can be linked together through entanglement. Albert Einstein hated this. He called it spooky action at a distance. Basically, if you tickle one qubit, its partner laughs, even if it's on the other side of the galaxy. Chapter 2, The Villain Decoherence. So we have these magical spinning qubits. They can calculate things exponentially faster than the best supercomputers. Sounds great, right? Here's the catch. And it's a big one. Qubits are divas. They are incredibly, frustratingly sensitive. This is the biggest hurdle in quantum engineering decoherence. Decoherence is when a qubit loses its quantum magic and collapses back into a boring old 0 or 1. What causes this? Literally everything. A stray air molecule bumps into it. Crash. A single particle of radiation hits it. Game over. The temperature rises even a tiny fraction. The math breaks. Making a quantum computer work is like trying to build a house of cards inside a tornado. To verify this struggle, researchers usually work with individual atoms or superconducting circuits. But these things are so fragile that if they get any hotter than the deepest, darkest void of outer space, they fail. And that brings us back to the gold chandelier. Chapter 3, The Reveal the Chandelier as a Fridge. Here is the plot twist, that giant, beautiful golden structure. That is not the computer. This tiny chip at the very bottom, small enough to fit in your palm, that is the computer. The giant chandelier above it. That is essentially the world's most expensive, high-tech refrigerator. It's called a dilution refrigerator. Its entire job is to create an environment so cold, so quiet, and so empty that the qubits on that tiny chip don't freak out. The chandelier shape is functional, not decorative. It works in layers like a wedding cake but for temperature. The top is cold. The middle is colder. And the bottom, where the chip lives, is mere millikelvins above absolute zero. That is colder than deep space. It creates this freeze using a mix of helium-3 and helium-4 isotopes. The gold plating you see. That's gold-plated copper, used to conduct thermal energy away from the chip while reflecting heat. So when you look at that steampunk chandelier, you're looking at a fortress designed to protect a few microscopic atoms from the chaos of our warm, noisy universe. Chapter 4. The Reality Hype vs. Science. Now with machines looking this cool, it's easy to get carried away. The hype train for quantum computing is moving fast. In June 2025, we saw billion-dollar buyouts in the industry. Governments and tech giants are in an arms race. But we need to pump the brakes a little. We are currently in what experts call the NISQ era noisy intermediate-scale quantum. Noisy means we still have a lot of errors. The qubits are still decohering way too often. Think of quantum computing right now like Taylor Swift. Everyone talks about it constantly. It's on every news feed. It sells out stadiums, or in this case, attracts billions of dollars. But just like not everyone who buys a ticket actually knows the lyrics to All Too Well, not every company claiming quantum advantage actually has a useful product yet. The hype is louder than the music. In fact, skepticism is healthy. Professor Jonathan Oppenheim, a physicist at University College London, has openly criticized the over-optimistic claims of tech giants like Microsoft, reminding us that we haven't fundamentally solved the error correction problem yet. There have been times when companies claimed a quantum computer did something in seconds that would take a classic computer 10,000 years. But then scientists tweaked the classic computer code and did it in a few days on a laptop. So are they useless? No. But they aren't magic wands yet. Conclusion. Quantum computers might eventually revolutionize medicine, create new materials, or crack encryption codes. But for now, they remain beautiful, finicky experiments chilling at the bottom of a golden refrigerator. We are witnessing the infancy of a new physics. It's messy, it's expensive, but it is undeniably fascinating. What do you think? Will we ever have a quantum computer in our pocket, or will they stay locked in these golden cages forever? Let me know in the comments below. If you want to stay updated on the future of technology without the confusing jargon, make sure to hit that subscribe button for Quantum Files Official. We decode the universe one file at a time. Thanks for watching and stay curious.